Hi guys, welcome to In 5 Minutes. We are handling memory management and the next topic is memory protection. It's a continuation video from the paging section. We already said that paging is taking part of a memory, creating logical pages and putting into physical address frames. But now let's understand whenever we are doing this, pages are cached data. Now what do you mean by cached data? Data which is kept with the application so that we can perform certain operations onto it. Now during you have a page, there has to be obvious protection to that page. Now how this is gonna be achieved? It is gonna be achieved by simply some bits. We'll associate some bits to some protection mechanism and would decide what can be done with a page. This protection is fairly simple, whether you can read, whether we can write, whether you can execute, or whether the page is valid or not. Let's try to understand them. When we talk about protection bits, we have two basic things to talk on. Number one, the validity bit. When we talk about the valid bit, it is whether the page is physically valid or not. Why this so happens? Sometimes when you cache a particular page and that has been altered, this bit needs to be set, because once this bit is set, the application which is accessing this particular page would understand that page is no longer valid and it needs a refresh. It is also used when we want to write back a page to a storage. That means I have taken some data, I altered it, and I want it to go back to the permanent storage. So valid invalid bit will be used in two ways. Other three bits are read, write, and execute. Now depending on if they are 1, they are read, write, or execute. Depending on their 0 means they are not. Let's try to understand this concept in a easiest manner. Let's see what we have right now over here. We have a virtual memory, a page table, and the physical memory. Now if I number the frame 0, 1, 2, 3, 4, 5, 6 and 7, so 8 frames, 0 to 7. Let's see this mappings here. Page 0 is in page 1. Page 1 is in frame 4, is in frame 4. In third we don't have entry, so in fourth, that is page number 3 at the fourth location, it is at the last page. Now this mapping is clear. That means here we are talking about the page, here we are talking about the frame. But next to that, I'll just rub out the frame part so that we can see. Let me just undo it. But this is page, this is frame, that is very clear. And here we are seeing whether it is valid or not, whether it is readable or not, whether it is writable or not, whether it can be executed or not. So in seeing this, we would understand that when it comes to page 0, which has the protection bit as 1100, that is 1100 rather, the page is valid, the page is readable, but you are not allowed to write or execute it. So now looking at page 1, which is in frame 4, it is valid, it is writable, it is readable, but it cannot be executed. Similarly, the last page, that is in last frame, page number 3, what we have is, yes, it is valid, yes, it is readable, yes, it is writable, yes, it is executable. Using these schemes, we always keep our pages protected, either for consistency issue or for read-write conflicts. This may also be used in achieving read-write conflict solution, because if a particular page is being written by some, it may not be read by others. So read bit goes 0, whereas the write bit only by one process for that particular page goes 1. Even for the protection purpose, we have execute, whether you are allowed or not allowed to execute. So that is used as a memory protection. So turning things very quickly again, we say for the protection we use bits. There are 4 bits to talk about: valid bit, read, write and execute bit. This is checked by the MMU, that is Memory Management Unit, for each and every access. With the final diagram, we have shown mapping and what pages are capable of doing. So it's a very simple and straightforward concept, yet very important. That's it. Thanks for watching this video.